Okay, we're not gonna have a quiz today. We're gonna jump right into some review. And in the MDE 61 class, I pretty thoroughly reviewed what's going to be the first problem in the test. Now, the first problem in the test will be a reciprocal function, or for a squaring function, or an exponential function. And you know what it's going to be. It's the same as it was on the major quiz. Okay? Hey, there's a 1 in 3 chance you'll get the same function you got on the major quiz, but that's random. Okay. Well, the question was for the reciprocal function. Okay, so we decided to do the reciprocal function. So here is the reciprocal function. I'm going to go over this quickly. You can see the whole video and get all the details because I addressed a lot of the problems that I saw people having with this. Okay. And a lot of the things people have apparently forgotten in the 2.5 months since we did it in class. Okay. So you can't forget this. This is really as fundamental to the course as anything we've done. Okay, so we're going to do a reciprocal shape in a 4x4 rectangle with the red dot at 12, -14. Well, red dot goes in the middle on a reciprocal function, goes in the middle of the lower edge for squaring or an exponential function. So there's the red dot. It's getting kind of faded. Let's make everyone look where everybody can see it. There's a big old red dot. Okay. And we start by drawing a vertical line and a horizontal line through that red dot. And those lines, of course, are going to cut the rectangle in half vertically and horizontally. And we do the construction lines. We go halfway from the middle to halfway from the right edge to the center line to get this line. We go halfway from there to the center line to get this line. And then we do the same thing from the left. Everybody knows how to do this, okay? People didn't do too badly on constructing the lines on the major quiz, okay? Although everybody needs to be very sure they know how to construct the lines for each of these functions. For this particular function, here they are. Halfway from the top edge to the middle, and then halfway from there to the middle. Halfway from the lower edge to the middle, and halfway from there to the middle. And then we put the numbers on it. And here's where people often had trouble because people don't seem to understand the numbers and the coordinate system very well. Okay. It's because you haven't had to think about numbers that much. You've just put them in your calculator and that's the end of it. Okay. And that's the way it is in K through 12, pretty much, in most courses. Okay. So you really have to understand the numbers. Okay, well, the understanding of the numbers is simply, and many of you do, many of you got numbers right, but I see things that don't have any relation. This is a 4x4 rectangle. So I'll see people who know that this has got to be x equals 12 because 12 is the x coordinate of the red dot. And this line in the middle is y equals -14 because y equals -14 at the red dot. That was given. Okay, that's where the red dot is. But then people might put 4 here and -15 over here, which makes no sense at all. First place, -15 should be to the left of 4. Second place, from 4 to -15 is 19 units. This is a 4x4 rectangle. It's 4 units wide. Okay. And if you don't have something where this number is 4 more than this number, you don't have a 4x4 rectangle. And if this number here isn't in the middle of these two numbers, you don't have it done right. Okay, so you got to figure out how far you have to go here and how far you have to go here and what numbers go here. Went over that quite a bit in the video. I'm not going to go over it now, but that's a common error. Get ridiculous numbers here and here from half the class. Okay. And again, as a whole, this class did pretty well with constructing these things. Everybody did it perfectly, including people who dropped the course. When we did it in a quiz in the first week, the second day of class, maybe the third day. Okay. Of course, it took us a month to have 3 days of class with all the closing. People did it. People made these graphs perfectly. Everybody did it perfectly. Okay. So make sure you can do that. And again, I saw pretty good construction of these graphs on the major quiz. When it came to the numbers and things, it wasn't as good as it had been a couple of months earlier. Okay, then we make some estimates. We estimate y for x equals 10.5. How do we do that? Well, x equals 10 here, x equals 11 here, so 10.5 is halfway between. We draw a vertical line here, and then we see the point where that line hits the graph, and we make a horizontal line here. Now, some people in the MD 61 just immediately drew that point and drew it in the right place. That's good. And if you draw it in the right place and tell me what the coordinates are and they're reasonable, okay. But I really think you're best off if you draw the vertical and horizontal lines through these points so you can make good estimates. Well, I did all that and then I screwed up the estimate. So, you screw up the estimate, but you've done the right things. You're going to discover it when you complete the problem. Okay. As I did, and then I fixed it. Okay. And my error here, I estimated this as negative 14.2 because it's about 0.2 of a unit below this line. But this is a 14.5 line, not the negative 14 line. So it's easy to do that. I did it. Okay. So, just silly little clerical things. I'm going to ding you a point. Okay. If it makes no sense at all, it'll be more than a point. If your point isn't anywhere near where it should be. But if you got the point in the right place and mess up your estimate a little bit, depending how badly you mess it up, I'm not going to be too punitive on it. Okay. So anyhow, then we estimate x for y equals negative 12.7. So we got to draw y equals negative 12.7. Look, I did another dumb thing here. I didn't put a negative sign in that 12.7. Okay. But it's clearly, that's where it would be. And then we draw the point in the graph and draw the vertical line and write x equals 12.9 there. So there's our estimate. Y equals negative 12.7 when x equals negative 12.9. All right. Now, again, people are pretty good with estimates. Okay. But what has been either forgotten or not really locked in is how to get these numbers on the graph. Okay. And they've all got to be there and they've got to be right. Okay. If you mess up those numbers, it's a little bigger deal than just, making a clerical error on your estimate. Now, having done all that, you have to make sense of it because this is what the problem's going to ask you to do. Okay. So it's going to ask you to give the g of x equals f of x minus h plus k form of this function. Well, you've got to know that this is a reciprocal function and it has formula f of x equals 1 over x so that you can figure out what f of x minus h is. Okay. So, here's what we do. I write out f of x equals 1 over x, then I write f of x minus h. We see that x is being replaced by x minus h. So we replace x by x minus h, and there is the expression for f of x minus h. Okay. So that f of x minus h plus k is 1 over x minus h plus k for this function. If it was a squaring function, f of x would be x squared. So f of x minus h would be x minus h squared. Okay. If it is the exponential function, is 2 to the x. So your f of x minus h would be 2 to the x minus h. You don't memorize that. You just learn how to use function notation, which people did pretty well with when we did it. And not as well on the major quiz. Okay. So what I emphasize is you really have to review, stuff that you would do perfectly a couple of months ago was done somewhat imperfectly. And you need to put it all together, okay? So be sure you're reviewing. Go back to the problems that I emailed you. Incidentally, if you're using an Apple, as I only discovered when one of you asked me, brought in a computer and showed me that it's showing the HTML, and it's making less sense because there's all kinds of code in it and everything. If you're using an Apple, it turns out that you have to download it and then open it. Okay, so if you're using an Apple and your document isn't nicely formatted and you forget what I just said, email me and I'll tell you again. Okay, it's just simple. You just download it and then open the download. I think I don't use Apple. I have good reason not to because they're not compatible with most other things in some aspects. Now, I've been sending these things out for years, and this is the first anybody that showed me what an Apple does to that file. It's clearly an HTML file. It even has an HTML extension, and Apple opens it as a text file. That's really dumb, okay? Apple does a lot of great things. There are some great advantages, but that strikes me as one of the dumbest things I've ever seen a computer do, a computer system. No offense to Apple. Yeah, okay, take offense, Apple, if you like to. There's a valid criticism, get on the ball. Okay, because so much of the other stuff you do is so wonderful. But get with the system. You've only been around for 30 years. Okay. Graph is this. So right there is your function. Now, what's H and what's K? Well, you should know H is a horizontal shift, K is the vertical shift. Now here's a picture. Okay, here is this graph. Okay, you can't see all the details because I had to write them really small. Seriously, this is where it is. Here's your x-axis, here's your y-axis. It's x equals 12 and y equals -14. Right there's the red dot. That's where this graph lives in the coordinate plane. Okay. Here is your toolkit function, where H and K are both 0. Okay. The red dot is at the origin. You take this thing and you shift it 12 units right and shift it 14 units down, and you get this. And the code for that graph then is u of x is 1 over x minus 12 minus 14, because H is your horizontal shift and it's 12, and K is your vertical shift and it's -14. There's code for your function. Now that we know what the code is for the function, we can see if our estimates in our graph make sense. Well, we estimated that x equals 10.5 and y equals -14.2. If x equals 10.5, y should equal -14.2. So what do? G of x is this, so we let x equal 10.5. Okay? So here's G of x, 1 over x minus 12 minus 14. Here's G of 10.5, x is 10.5. We do the arithmetic and we get -14.7. Okay? That's our y coordinate because y equals G of x. Okay? Well, what was our estimate? I said the estimate was -14.2 because I did a bonehead thing here. The estimate really was -14.7. You can see it. That is the coordinate for this point. I've corrected it, but I messed it up. And in the process of checking it, I couldn't figure out why I was off by that much. Being off by 1 or 2 tenths is easy. Being off by half a unit, no, something had to be wrong. Okay. And my graph is no better than most of the graphs I see you making, and many of you are making graphs much better than mine. Okay. So then everybody's making decent graphs, even if they're not quite as good as this one. They're usable, and you should get good estimates. Okay, so now that I've got the estimate right, I see that the estimate is exactly, well, not exactly, but to the nearest tenth is the same as what the function gives us, okay? Then we estimated the x value for which y is negative 12.7. Well, I pointed that out, and we got negative 12.9. Now we got, yeah, y should be negative 12.7 if x is negative 12.9. Well, if we plug in x equals negative 12.9 here, we get negative 12.9 here. Everything else is the same. So we get 1 over 12.9 minus 12 minus 14. That's written a little small. You might have to look at the video. But we're just plugging 12.9 in here, and we get negative 12.9. We don't get negative 12.7, but that's not far off. Okay? So, my graph, and when I made my graph, you notice that I kind of missed this point. Notice that my curve didn't curve enough, and I commented on that. And let's just see that. I commented on that in the pre-staging class when I made it. I didn't get the curve quite right there. Okay. It should have gone through this point, so it should have been curvier, which would have moved this estimate over a little more to the left and given me something that probably matched better than what I actually did estimate. Well, if you did the same thing, I wouldn't penalize it at all. Okay? I expect little glitches. I don't expect you to be an artist through graphs. Okay? I do expect you to do a reasonable representation. Okay? So if you tell me that y should be 47 when x is negative 10.5, well, you're not getting credit for that one. Okay? Because that's way off. All right. I kind of recommend that you do this. I'm not going to require this. This would be a good sketch to make. Okay, just show me where in the coordinate plane this thing would be to show me that you understand the coordinates. If you have a good picture of this, I'd probably forgive some little glitch that you made up here. Not a big one, but a little one. Okay. Make a 1 or 2 point glitch up here and have this picture in a reasonable scale. I might tend to be a little bit forgiving because I'm not asking you for this. All right. You remember all that? Remember doing all that? Now, if you don't, you're going to have to refresh your memory. And you can go back over the video, which is a lot more, it runs pretty much for a whole class. We talked about a lot of the things that I saw on the major quiz that you really want to get right this time. Okay. All right. Now let's see. I hope I was recording that. Yep. A couple other things that arose. There's a problem in the problem set. It's an applied problem where you have a tree I'm changing the situation a little bit. We're not talking about months, we're talking about years with this tree, okay? But it's got a diameter of 14.2 inches in May, and it's kind of a fast-growing tree, okay? And the diameter is 15.7 inches. In August. Okay, well, think what I ask you to do with this problem is represent this information on a graph. Tell me what the linear equation is and use the linear equation to make estimates. And it might also have something to do, and if it doesn't on this problem, it will on another, with doing a fundamental triangle. Okay? So I'm going to do that. And this is fairly easy to dispose of. Okay? You sketch a graph. Actually, you can just sketch 2 points. Okay? And you're going to let t equal 5 here. T equal 8 here. Be a reasonable thing to do because you're going to graph the diameter versus the time. The time in months. May is the 5th month, August is the 8th month. Okay? Now I could give you dates, May 14th and August 27th, and you'd have to figure out all the days. I wouldn't do that to you. Okay? You just say, okay, here. And I think the way that actual problem is stated, it's just in years. Okay? The year 2006 and the year 2014. So what is it today? Something like that. So reasonable thing to do would be label your vertical lines. T equals 5, T equals 8. And label your horizontal lines. Okay. Let y be the diameter. Y equals 14.2 by 2. Got too close to my decimal. Y equals 14.2. So okay. Now we're going to want the straight line through these points. I would say it's y equals mx plus b. Now you have choices. You could use the formula, y minus y1 equals y2 minus y1 over x2 minus x1 times x. Okay? And so forth. Times x minus x1. There's a formula, if you remember it. Okay. Safest thing to do if you're not sure about memorizing the formula. And something that I might well ask you to do anyway on this problem or a similar one is label your fundamental triangle. So I'm drawing my fundamental triangle here. I could have drawn it down here. Be similar triangle, have the same rise and the same run. And remember, we like to draw arrows from the leftmost point to the rightmost so that we're sure we don't mess up the sign because I saw too much of that. Okay. So this is, and this is how we label it. Now I'm going to be more strict in grading how you label fundamental triangle. I've emphasized it many times. Everything I'm writing down here should be written down if you're asked to do the fundamental triangle. Even if you're not asked, it's a good idea. Rise equals 15.7 minus 14.2 equals 1.5. Run equals 8 minus 5 equals 3. Down here, slope equals rise divided by run equals 1.5 over 3 equals 0.5. The box here next to the hypotenuse, next to the sloping part of the fundamental triangle, 0.5. So I can immediately see the numbers I use to get my rise and how they're used, the numbers I use to get the run and how they're used. A quick explanation, slope is rise over run, etc. And then a box around the slope here. So I can immediately look at my graph and see what I need to see. Okay, now the equation of the line. Slope 0.5. Y equals 0.5x plus b. Find b. Use either point. Now let me just make a plug for when you do your homework, you write things out in detail so you retain them. Okay? Because as a class and almost every individual, you've been doing really well on the quizzes. Okay, meaning you come to class prepared. What I didn't see was preparation for the major quiz. Review of the things that you did well the day after you did them for homework, okay? You have to review your homework. You have to review the course. You have to review the high points. And a good place to start, because I've given you about 30 problems that are representative of the problems you're going to see on the test. There are 10 problems more or less in the test. Okay? To be able to do those problems, you might have to go look it up. Again, I will put in a plug. When you do your homework, write out what you're doing. Tell yourself what you're doing. You'll retain it better and you won't get to the midterm exam or major quiz unprepared. And you might still be somewhat unprepared because there's a lot of detail there. But at that point, it only takes a brief review as opposed to 3 or 4 all-nighters, whatever it takes. Okay? You have to put the time in it though. And the best place to put the time in it is when you do the homework, do it thoroughly. So you tell yourself, you reinforce. I keep saying this. Now, when I was a freshman in college, I had a physics course. The physics instructor, professor, top-notch guy, really liked the guy. He's pretty old. I think he was in his early, maybe even mid-30s. And he was an expert on the physics of baseball. He had some pretty neat stuff there. But he was also a pretty good athlete. I'd see him, I'd spend a couple hours in the gym every day, and I'd see him there playing basketball with a pretty good bunch of basketball players. He's pretty good. Really nice guy. And we liked him. And I was doing okay in the course, but he said, when you come in, when you review for the exam, you should know everything, having done it thoroughly all the way through with just a brief review. That's all it should take. I thought, that's crazy. Nobody does that. Okay? So, if you're in the same situation I'm in, okay, you might think I'm crazy, but this is good advice. Eventually, it stuck with me and it benefited me. Okay, not so much in that course. I made a B and almost made an A, but that was back when A's were really hard to get. So I did okay, but had to do a lot of reviewing. All right. And I never did understand the course as well as I could have. That's all there is to it. Okay, back to point here. What do? We construct a fundamental triangle, we draw the line, we draw the graph, we label everything, so we have everything in our head. And then we say, okay, well, I know the function is y equals mx plus b. Now the slope is 0.5, so y equals 0.5x plus b. We can use either point to find b. Using the point, we'll just use 5, 14.2. Y equals 14.2. When x equals 5. It's worth reminding yourself of that and writing something like this out. You get you get 14.2 equals 0.5x plus, sorry, it's kind of automatically right, x, so 0.5 times 5 plus b. In other words, x equals 5 goes there, y equals 14.2 goes there, because there's the equation. This is where y is, this is where x is. We get 14.2 equals 2.5 plus b. So b equals 14.2 minus 2.5 equals 11.7. If I did my arithmetic right, which is always questionable, I think that's right. Okay. So there's the equation of the line. Now I'll typically ask you, okay, tell me. Now for a tree growing month to month, it doesn't make a lot of sense for me to say, well, okay, what's the diameter going to be? And, 4 years later, because, you got winter where the tree doesn't grow. You don't know, the line is not going to be straight. It's not going to stay straight. Okay. I'm not even sure what the profile for growing tree is, but it's not linear. Okay. I think early in the spring, it's busy making its leaves and, pollen and all that stuff, seeds. And then for the rest of the summer, it starts putting on more wood. Okay. So I think it's not linear, but we're going to assume a linear model. And let's then ask, if the linear model is accurate, why? Well, July is month 7. So y should be 0.5 times 7 plus 11.7. Well, that comes out 3.5 plus 11.7. 15.2. Now, does that make sense? Okay, well, you come over to your graph. T equals 8 there, T equals 7 should be about here. It's not very accurate, it should be a little clearly that way. But here's the point on the graph. Is y equals 15.2 makes sense? Well, 14.2 to 15.2 is 1 unit. This is half a unit. So this is 2/3 of the way from here to here. And t equals 7. Well, I wrote a really bad 7 there, but t equals 7 is 2/3 of the way from 5 to 8, isn't it? So it perfectly makes sense. So we see that the equation has some use. Not particularly useful for a tree growing from month to month. But the way the problem, I think, is stated, it's over a period of years. Okay, so it's like give you the diameter of 2005, the diameter of 2012. Tell me what the diameter is going to be in 2035. Or tell me what the diameter was yesterday. I want to ask you that. I could. Oh, makes sense. So if you do those two things, it's a pretty good start. Because you're certainly going to have an applied problem. You're certainly going to have a problem about a graph. Okay. Now, couple of problems here, situations we can dispose of fairly quickly. Let's say you have see what we're doing here. Y equals 2x squared plus 8x minus 10. Right. Now, this is something we've done very recently, so I'm just going to kind of write this down pretty quickly. And this should jog your memory, because people have been doing kind of okay with this, okay? What do we do? The zeros, 2x squared plus 8x minus 10 equals 0. X equals -8 plus or minus the square root of 8 squared minus 2 times -10 times, sorry, 4 times 2 times -10 over 2 times 2 equals -8 over 4 plus or minus square root of, that's 64, and that's 80, 144. Left out, I got a perfect square. Being careless with what I write, focused on getting that number. I think I did that right. 100 square root of 144 over 4. Yeah, the 4 here and the 4 here come from 2 times 2, right? It's the denominator for -8. It's also the denominator of 144 by the distributive law. Okay, so that's -2 plus or minus square root of 144 is 12. 12 over 4 is 3. Now, I'm not writing out all the details. In general, you probably won't get a perfect square, or that was just dumb luck. Okay, I wasn't even trying. There are a lot of squares in that vicinity, so get a perfect square. It's dumb luck, but your calculator will give it to you. You know, to nearest tenth is usually okay, right? At least 2 significant figures. 3 is actually sometimes better, but for constructing the graph, anything close is going to be okay. Now, the graph has to be done right. A -2 plus or minus square root of 3 is 1. Well, let's do, it's -5 or 1. So here's x equals -5. Here's x equals 1. And here are your zeros. your y-intercept at 0, -10. So here's your y-intercept all the way down at -10. Something isn't making sense. Okay. Probably screwing up this graph. It is not going to rise that much between the y-intercept and the 0, even with a 2 there. Anybody say anything wrong with my numbers? I'm honestly flummoxed a bit. Uh, oh. 12 over 4 is 3. This graph is kind of screwed up. You screwed up as bad as I did. I'm not going to penalize it real heavily, but something's not going to make sense. Okay. What else do you want on the graph? The axis of symmetry, which is halfway between your zeros, which is at x equals -2. Okay. So the axis of symmetry, which you can always see in the quadratic formula, is right here, is x equals -b over 2a, which is -2. The vertex x equals -2. So y equals 2 times -2 squared plus 8 times -2 minus 10, which equals 8 minus 16 minus 10, which is -18. Now, according to my numbers, the axis of symmetry is going to be lower than -10, which it had better be, because you know the graph has got to look like this. So I can put y equals -18 here. Of course, I probably want to put my y equals -10 line here. So here's my vertex. Now my graph comes down here through here, up here and up through this point. It's a little wobbly there, and it shouldn't be. It should be constant concavity, but that's kind of what the graph might look like. And actually, I can reconcile that, so I probably didn't screw up, because I checked the numbers pretty carefully. Okay, so something didn't quite look right to me, something didn't quite feel right. Even though I had a 2 in front there, I thought it was too steep here, but now when I draw it, it looks reasonable. If I draw it and if the vertex was above this point, you know that couldn't be. It's got to come down to the vertex and turn around. It would never get down to the y-intercept, right? Then you would know you did something wrong. But that's how you graph quadratic function in general form. Thank you. How do you graph y equals x minus 2 squared minus 5? Well, this is vertex form. Y equals a times x minus h squared plus k. A equals 1, equals 2. Okay, -5. So the vertex is HK equals to -5. Vertex is at y equals 0 minus 2 quantity squared minus 5 equals -1. So what do we have? We have the vertex at 2, -5. So there's x equals 2. Here's y equals -5. Here's the vertex. Y-intercept is at y equals -1. It's on the y-axis, so you're going to have y equals -1 here. Here's your point on the y-axis. Now we can sketch a graph. We could put more detail into it if we wanted to, but it's not very well drawn. But the graph might look something like this. Now, I haven't determined what the x-intercepts are, but the x-intercepts are when y equals 0. That you just have to know that the y-intercept occurs when x equals 0. In terms of the graph, you should understand why. If y is 0, you let y equals 0 and you get an equation that you can solve for x. Uh, you square x minus 2 using the distributive law. I'm not going to write the details of that, but x minus 2 times x minus 2 and use the distributive law. That's right. A little small, but right there it is, -4 plus or minus square root of 8 over 2. Approximate that with your calculator if you need to. You're going to get like square root of 8 is about 2.8. You're going to get like negative. Okay, the graph got it wrong. You get like a negative 3.9 and 0.6, but it should be negative 0.6 and 3.9. It makes sense. Anyhow, I'm going to say et cetera there. I'm going to wave my hands at it and say, figure out what I did wrong and do it right. Okay? But what you would do is you would set this equal to 0, expand this, get this, and do this. You're probably not going to have to do this, but on the major quiz, but you might well by the time you get to the final, so it's worth looking at. Okay. All right. So that's what I'm going to say right now about graphing these functions. There are other twists and other examples that you need to look at. Problem that could occur where you solve a quadratic inequality. Now you've seen these. There's one or two of them in the assignment quadratic functions in open math. Okay. If I'm wrong about that, I think I checked it, but if I'm wrong about that, then if this problem would occur, I wouldn't, I don't know if you got it right. But it's one I think that you're responsible for because I think you did see it. To solve this, all you do is you graph this function. Okay. The zeros are at x equals 1, x equals 4, equals -3. So here are the zeros. The y-intercept is at y equals 12. And your graph like this. That'd be a very easy polynomial graph. My point is that to solve this inequality, you draw the graph. So this graph is y equals x minus 1 times x plus 3 times x minus 4. It's not written very well. I've just rewritten it here. So y equals less, y is less than 0 for what x? Well, give you a hint. Y is less than 0 everywhere below the x-axis. Make sense? So for what values of x is y less than 0? Well, it looks like y is less than 0 along this segment of the curve and along this segment. This segment of the curve corresponds to x values less than -3. That makes sense? If x is less than -3, y is less than 0. If x is between 1 and 4, y is less than 0. Right? Now I'm going to draw these with open circles from the end. So here, okay. So our solution interval notation would be -infinity, -3, union 1, 4. You could also write x less than -3 or 1 less than x less than 4. And unless I said to put the solution in interval notation, which I might or might not have done, you can check the problem. Okay? Then you could say it this way or this way. If you just draw this picture and identify the intervals clearly, shade them and so forth, I might penalize you a point or two out of 10 for not stating the solution. but you get most of your credit, okay? The point I want to make is the solution to this inequality or any inequality is if you graph the function, you can see where it's less than zero. Then you tell me what the x coordinates are, what's less than zero, okay? So actually, that's probably an easy problem because the polynomial I give you is probably an easy polynomial because all I'm testing is, can you graph an easy polynomial and tell me where the y is less than zero? Okay. Now, another situation that I had some questions on is there's a problem that says sketch a graph of a polynomial with zeros. Polynomial has a degree of 6 or 7 or 8 or something like that. Okay. So let's say I say polynomial with zeros at -3, 1, and 7, degree 6. Well, you've only got 3 zeros, but the thing's going to have a degree of 6. I'm not sure how it's stated, but I think it's stated in such a way. Well, my scale isn't great here, but that's all right. Got zeros here, here, and here. If the degree is 6, you have to reason out the end behavior. Okay. What I said isn't so. I got to look at them. Okay, here's the main point. Okay, could be like this. That's possible. That clearly has degree 6, right? Well, not so clearly, but this would be a 0 multiplicity 2. This would be a 0 multiplicity 2. This would be a 0 multiplicity 2. This would be like x plus 3 squared would have parabolic 0 at x equals -3, right? Because if you just look at x plus 3 squared, you're shifting the y equals x graph 3 units to the left. And there it is. Okay. So this is like x minus 3 squared, x plus 3 squared, sorry. This is like x minus 1 squared. This is like x minus 7 squared. Vertically stretched, but close to these points, it's like a vertically stretched quadratic, okay? Not perfectly so, but very close if you're very close to the points. Okay, so that's one way to do it. Another way to do it. You got your 3 zeros here. You come on down through this 0, come up through this one, down like this, up here. And it's like a cube here. So that would be degree 3 or multiplicity 3. Multiplicity 1. Sorry, that's multiplicity 2. And multiplicity 1. In other words, this is like x minus 1 squared with a vertical stretch factor and a reflection. Okay, it's reflected because it's negative. This is like x plus 3. And this is like x minus 7 cubed. Understand what I'm talking about? So show me, you only have 3 zeros, not allowed to add any more. Okay? And the degrees of those zeros should add up to 6. And if it's degree 7, well, so forth. And I think you can do it. I don't think you need any degree over 3. Degrees would be 1, 2, or 3. So you want to understand that about polynomials. Okay. Now, we've still got about 20 minutes. What else would you like to see? Okay, just briefly. Again, inverse functions, you switch x and y. Whether you've got a table or a formula, your x's become y's, your y's become x's. In your table, your columns switch. On a function, you replace x by y by x, and solve for y. Okay? If it's just a graph, you just switch x and y and sketch the graph. And then make estimates and so forth. Piecewise function, you'd have F1, F2, F3. Typically, F1, F2, and F3 are 3 different toolkit functions. So what I started out with here is a graph of F1, and that would be this parabola here. That'd be a quadratic function. F2 would be an exponential function. That would be like this one. F3 would be a reciprocal function, be like this and like this. Now, if you have F1 of x on interval 1, of course, interval 1 would be like -2 less than x less than 0.5 or something like that. Well, here's interval 1. You shade the squaring function, okay, on that interval only. And preferably kind of erase the rest of the squaring function because it only applies on that interval. So maybe you erase the rest of this squaring function, or at least lightly erase it. Be sure that we don't think that's part of the graph, because it's not part of this toolkit function, okay? Then on interval 2, well, let's say interval 2 goes from here to here. Goes between these 2 vertical lines, okay? Indicated here. Now, there's nothing between here and here. That's not one of the intervals of definition. So you don't sketch anything at all on that empty interval. But on this interval, you follow function 2. Well, if this is function 2, you follow that function for this segment. Okay, then interval 3 maybe is right here. and you shade in the third function, maybe erase parts of the third function. And you end up with these broken blue curves. You don't have to use blue, just make sure I can tell what's shaded and what isn't. Fair enough? Okay. Now let's see what else might want. You should also do, like on the tree growth model, if you're given applied information on any problem, pretty much on this test, where you're given applied information, you want to put the points on a graph. If you're asked to find a rate of change, you want to do a fundamental triangle. Now you can, if I don't say do a fundamental triangle, you can do it by the definition of rate of change, change in y divided by change in x. But I do like to see the fundamental triangle. If you do it both ways and have the fundamental triangle and screw up the other way, I'll probably just count the fundamental triangle, okay? And if you do a good job of stating the rate of change in the definition, then I'll probably look favorably on that, okay? Doesn't have to be one or the other unless I specify it. Okay, got just another minute or so. Quickly, somebody the cubic function. Graph in the rectangle, red dots here. You do 1, 2, 3, 4, 5, 6 subdivisions toward the lower end. And then you have 3 more subdivisions between that last one and the lower end that you're not able to draw. And you then go from here, left 1, down 3, left 1, down 3, and then left 1 and across those 3 virtual lines, and you get to the origin. And we did that in detail in class within the last 2 weeks. I'm not sure which class it was.